Okay, so it has all the notes that you need right here about growth or decay functions. We already know that the difference is if your base is greater than 1, it's going to grow from left to right. If your base is less than 1, it's going to decay from left to right. It's going to decay towards your asymptote. We already know that the asymptote is the k value y equals k, which in this case would be the asymptote y equals -2. We already know all these things. But let's get just straight to practicing. Once again, we're going to graph exactly the way we did before when what was a growth function. Now we're just going to have a decay function. We're going to ignore h and k. And in Algebra 1, we don't even have any h values, but we do have a k value, which is -2. We ignore it. We do an xy table. We're going to plug in some consecutive integer inputs. Check it out. -3, -2, -1, 0, 1, 2, 3. Now you can plug in any number you want. Which one's the easiest? Plug in 0. Anything. Not just 1/2, but anything to the 0 power is what? 1. So when you plug in 0, you get out a 1. Now you could, if you wanted to, plug in a 1. If you plug in a 1, what's 1/2 to the 1? 1/2. Okay, so you get a 1/2. Or if you wanted to, you could plug in something like -3. Now that'd be kind of weird and it'd be a lot of math. 1/2 to the -3 power. Think about this. 1/2 to the -3 power. That means that I'd have to distribute the power of -3 to both, and it'd be 1 to the -3 over 2 to the -3. But then those -3 powers would have to flip. So you'd end up with 2 to the 3 over 1 to the 3, which ends up giving you 8. It takes a long time, but you could get there. Now, what's the shortcut? I always say, don't do the math. Just understand that this base value is either your growth or your decay factor. So, pick any easy output, any easy answer that you got. So you originally plugged in 0, you got out a 1. That's an easy answer. You're going to make it decay by what? By half. Now, what do I mean by that? From this output to the next one, it's going to decay by half. In other words, 1 times half is half. What's the next one going to be? Half times half is what? 1/4. And the next one, 1/4 times half is what? 1/8. So if you're multiplying by half this way, backwards would be multiplying by what? By 2. If you were multiplying by half this way, backwards would be multiplying by 2. Or you could think of it, you're dividing by 2 this way, so you have to be multiplying by 2 this way. Right? Half times 2 is 1. 1 times 2 is what? 2. 2 times 2 is? 4. And 4 times 2 is? 8. We already have that 8 right there. So you see how it's really easy to ignore your k value, make an xy table, use consecutive integer inputs, plug in an easy number like 0, get out a 1, and then after that just use this value to get to your next output. 1 times half gives you half. Half times half gives you 1/4. 1/4 times half is 1/8. Backwards it'd be multiplying by 2. Times 2 is 1/4. I mean technically it's 2/8, but you reduce it down to 1/4. Times 2 is 2/4, which is 1/2. Times 2 is 1. Times 2 is 2. Times 2 is 4. Times 2 is 8. Let's graph these different coordinates. 0, 1 is right here. Everybody follow along, please. The coordinate 1 and 1/2. 1 on the x, halfway up on the y, it's right there. 2 and 1/4. 2 on the x, half of the halfway up right there is 1/4. And we already know that it's going to infinitely get closer and closer and closer, but it never actually touches. Even though we draw it like if it is touching, it never actually touches, just infinitely approaches. Going to the negative side on the x is -1, you get a +2. So -1, +2 is right there. -2, +4 is up here. -3, +8 is up here. And this is our parent graph. It's not our actual final graph because we have not considered the k value of -2. The k value of -2 means we're going to have to shift every single one of these coordinates down 2 units. Or you could start by saying this. I know that my asymptote is y equals -2. So you can even write that down. The asymptote is y equals -2. And you could actually draw that y value of -2, make it a dotted line. There's your asymptote. That way you know you need to shift all your coordinates down 2 units. So let me do this in black. I'm going to shift that one down 2 units, this one down 2 units, this one down 2 units, that one down 2 units. And even this halfway point is going to shift down 2 units to that halfway point. And we already know that it's going to infinitely approach that asymptote of y equals -2. So this is my decay function. You draw it, put some arrows on it, you're done. How about that top red one? That was your parent graph. Put 2 X's on it so I don't get confused and think that that was your graph. It's the black one, the one that got shifted 2 units down, that's your graph. Make sense? So it's the same exact process as before. And we could answer a bunch of things about this exponential decay function. How about the domain? X is what? All real numbers. Come on, guys. It's the same answer for all the domains of all these exponential growth or decay. Because X is, it goes to the left forever, goes to the right forever. X equals all real numbers. How about your range? Your range are your Y values. Y is either going to be above your asymptote or below your asymptote. What do you say? Y is above, and it's above what? Greater than what? -2. Greater than -2. Perfect. That's your range right there. Y is greater than -2. Now, what do we say our asymptote was? It was y equals -2. And how about our y-intercept? It's simply where your line crosses, where your graph crosses the y-axis. So that's a coordinate 0, -1. Now, do not go based off of this 0, because that's incorrect. That was your parent graph. But it's this one right here, 0, -1. That's your y-intercept. Now, if you wanted to calculate your y-intercept, set x equal to 0 on your original and include that negative sign. So if you plug a 0 right there, anything to the 0 power is 1, and 1 take away 2 gives you the output -1. So we're going to be doing the same thing on all these. How about this one right here? Is there an H or K? Is there an H or K shift? No. So I don't even, I mean, these coordinates that I come up with, those are going to be the actual coordinates. I don't have to shift anything. Let's do consecutive integer inputs. -3, -2, -1, 0, 1, 2, 3. We might not use all of them. Let's plug in 0. When I plug in 0 right there, what's 1/4 to the 0 power?
1.
And what's 1 times 8? 8. It is 8. So let's put 8 for the output of the input 0. You plugged in 0, you got out an 8. Now, is this growth or decay? Decay, because it's 1/4. So that means that the 8 is going to decay by that decay factor of 1/4. 8 decaying by 1/4, what's the answer? 2. Because 8 decaying by 1/4 is 8 times 1/4, which will give you 8/4, which reduces down to 2. Now, if I did want to get to the next one, 2 decaying by 1/4, that becomes 2/4, which reduces down to 1/2. Maybe we want to show our work here. 2 decaying by the decay factor of 1/4, that will become 2/4, which becomes 1/2. So I'm just going to put a 1/2 right here, but I think you already have the idea that it's going to decay down to what? Down to 0 on this parent graph. All right? The next one, if I wanted to get the next one, it would be 1/2 times 1/4. What would that be? 1/8. That one's pretty easy. 1/8. So what's happening? We're multiplying by 1/4, multiplying by 1/4, multiplying by 1/4. Or another way of looking at it is we're dividing by 4, dividing by 4, dividing by 4. Backwards would be what? If I divided by 4, what's backwards? Times 4. So what's this next one up? 32. Bless you. The next one up is 32, but I'm not even going to be able to use that on the graph. So I already have enough information to graph it, right? This guy is not even on the graph. Imagine that. Imagine -1, or here, -1 on the x, and then 32. You're way off the graph. So we're going to just use this one, 0, 8. Let's all graph 0, 8. That's right here, way up here. Let's graph 1, 2. 1 on the x, 2 on the y. It's right here. Let's graph 2 and then half. 2 on the x. So here's 2 on the x, and then halfway up. Not even to 1, but halfway to 1. So halfway up is right here. And then 3 and 1/8. 3 and 1/8. 1/8 is hardly anything. It's really close to 0. And that already gives you your perfect description of your graph. You know it's going to continue to shrink, infinitely shrinking, approaching the 0, but it'll never actually get there. It'll just infinitely approach it. So all you have to do is draw your line through these coordinates. And you have your decay function right there. So what is our domain?
All real numbers.
X equals all real numbers. How about our range? Y is what? Above or below a certain value? Above what? Above 0. So y is greater than 0. What is our asymptote? Y is 0. How about our y-intercept? Where does it cross the y-axis? 0, 8. 0, 8. And that's all there is to it, guys. Let's move on. Let's do this last one right here on the front side. So right here, we're going to ignore h and k, which there is no h, but in Algebra 2 there is. And we have this boxed-in equation. We're going to make an xy table. For that boxed-in equation, we're going to use consecutive integer inputs, -3, -2, -1, 0, 1, 2, 3. And we're going to plug in some easy numbers. What's the easiest number to plug in? 0. Plug in 0 right here. Anything to the 0 power equals 1. Anything to the 0 power equals 1. Now, I could plug in a 1 right there. Let's just do it for fun here. Plug in a 1. What's 2/3 to the 1 power? That's 2/3, right? So we'd have to write 2 over 3. And if I plug in 2, I could say that 2/3 to the 2nd power is 2/3 times 2/3. But you see, the easy thing to do, or the easier thing to do, is to plug in an easy number like 0, get out an easy answer like 1, and then multiply that answer by the growth or the decay factor. Now this is a decay factor because it's a fraction less than 1. So it's a decay factor, and we're going to multiply the 1 by that decay factor 2/3. 1 times 2/3 is 2/3. To get to the next one, I have to multiply by 2/3 again to get to the next one. So 2/3 times 2/3 is what? 4/9. 4 over 9. And to get to the next one, you're going to go 4/9 times 2/3 again. What's 4/9 times 2/3? 8, not 8/27. Man, I'm losing my mind. 8/27. Now, if you look at 2/3 on a calculator, 2 divided by 3 is 0.6. Actually 0.66, and it keeps going. But roughly it's 0.6. Imagine 66 cents. If you do 4 divided by 9 on a calculator, that's 44 cents. Roughly 0.44. It continues. If you go 8 divided by 27, what's that? That's 0.29. That's like 29 cents. So what do you think's happening here? It's getting smaller and smaller and smaller. It's decaying. But we already knew it was a decay because of the fraction being smaller than 1. Anyways, if multiplying by 2/3 got us to this one, if multiplying by 2/3 got us to this one, multiplying by 2/3 got us to this one, going backwards, it'd be dividing by 2/3, which is really the same thing as multiplying by the reciprocal. So if you say 4/9 times 3/2, it would actually give you 2/3. If you go 2/3 times 3/2, that would give you 1. If you go 1 times 3/2, that'll give you 3/2. And if you go 3/2 times 3/2, that'll be 9/4. And then 9/4 times 3/2 will be 27 over 8. And if you think about that, 3/2 is 1.5, roughly 1.5. 9/4, 9 divided by 4 is 2.25, roughly 2.25. 27/8, 27 divided by 8 is 3.4, about. 3.4, just about. Okay, so if we graph these guys, let's graph the first coordinate, -3 and 3.4. -1, 2, 3 on the x, and 1, 2, 3.4. It's almost halfway there. Once again, -1, 2, 3, up 1, 2, 3.4 is almost halfway up. Now let's do the next coordinate. The next coordinate is -2 and 2.25. So -2 on the x, 2.25, that's not even halfway. It's like half of the half. And once again, that was -2 and then 2 and then 0.25 of the way up. And then the next one, -1 and 1.5. -1 on the x and 1.5, 1.5 all the way up. So -1 and 1.5. 0, 1, that one's the easiest, thank goodness. 0, 1. 0, 1 is right here. And then how about this one? 1 on the x, 0.66. That's a little bit more than half. So 1 on the x and 0.66, it's a little bit more than half. What do you think is happening in this direction? Going towards the parent graph asymptote, which is y equals 0. So we might as well just start drawing our dots going towards it and even on it, even though we know it's not on it, it just infinitely approaches. Now, ladies and gentlemen, we could just put, we know that it's going to be going up that way also, but check this out, guys. This is not the actual graph. The actual graph has a k-shift. The k-shift is -3, so I need to move it all down 3 units. So this old parent graph asymptote needs to move down 1, 2, 3 to this new asymptote at y equals -3. All of these other coordinates need to move down as well, 1, 2, 3. So this is your new graph, and it's curving up in that direction. I would put 2 x's on the original so we don't make the mistake of grading that first one. And then you could state all that you can about that red graph. That's a decay function. The domain is x equals all real numbers. The asymptote is y equals that y value of -3. The range are your y values that are above or below the asymptote. What is it? Is greater than -3. It's above the -3 value. And then the y-intercept, well, it used to cross up here at 0, 1, but now it crosses at 0, -2. So the y-intercept is 0, -2. And that's all there is to do on this front side. If you need more help, watch the videos.